Good morning, everyone. Thank you for coming. Thank you for this opportunity to explain and speak about this research project. This is the VINESCOUT is a research project funded by the European Union with the Horizon 2020 program with 2 million euros. It's a 4-year project with we are in the end of the 3rd year, so we still have 1 year to go and many things to do. So the goal of the project is to design, build, conceptualize a ground robot for the vineyards. So yesterday we were talking, one of the sessions, the name was a robot for what? So this is a robot for taking the data that the grower needs to understand what's going on at the plant level. So this has 2 specific targets. First is to assess the vine vigor, which will tell the farmer how the canopy is growing along the season. And the second measure is water stress. We are at the front of an uncertain climate, so the environment is affecting the developing of the vines, especially in the south of Europe, where we are hitting temperatures above 40, 45 degrees in the field. We saw this every summer. So they want to get this data. Actually, they don't want to get the data. They don't care about the data. What they want is to have the information to do the proper management. And this information has 2 different aspects. The first is on irrigation. They have the infrastructure to irrigate, they have water, but they want to make sure that they apply the water in the right time. So for this application, it's important to get the data in the field and in a regular basis. And the second piece of information that they want is to help them to do zoning for harvesting. So in the field where we are working, they can only make 2 types of wine. So they make the regular wine, which is sold by 10 euro per bottle, and then they have the premier wine, which is sold by 30 euros per bottle. So this zoning has been traditionally made by the enologist, and was basically because he knew the field, and it was mainly because of the soil differences what they could make the zones. But now we have another parameters, which are the climate is getting some uncertainties to them, so they want to make sure that they will still be able to do these 2 types of wine, and of course they want to make more liters of the premier wine than the regular wine. So the solution we came up with, and this is the second prototype, so we still have 1 year to go. We have to make another robot in this year. It's a machine that the weight it has is about 100 kilos. It moves at 1.2 kilometers per hour and is able to map about 3.5 hectares per day. So it has steering like a tractor and a power source. It's 2 lithium batteries. So what's the actual challenge for us and the ambition? So first, our idea is to go to get high resolution data with proximal sensing, and I will explain both of them. First, here on the right, you see how the robot is working in the field. So this sensor here is the one that is measuring the canopy temperature. So we hear a lot of artificial intelligence. It's everywhere, it's being used everywhere. And the first thing is that when people say artificial intelligence, most of the times, they actually mean deep learning. So assuming that deep learning is the proper tool for agriculture, which is something that we could argue, but assuming that, we would need a lot of data. So we believe that we are not getting big data in the field because we don't have so many data. But with this machine, we are enabling at least massive data, which is the forerunning of big data. So I'm showing you 2 maps here. The one on the right is giving us the NDVI as a measure of vigor. So every cell is 2 meters by 2 meters, so we're talking about a resolution of 4 square meters. And you see that the sensor is measuring the NDVI at 50 centimeters from the leaves. We shift to the map on the left. This is a Canopy Temperature Map, and so these are rows of about 100 meters. And you see that the rows in the south have higher temperature than the rows in the north. So why is this? We started to get the data right after lunch. So it took us like 3 hours, between 3.5 hours to get the full map. Remember that the robot is going at 1.2 kilometers per hour in average. So the rows in the south were the last rows, and those were mapped around 4 p.m., 5 p.m., which was the highest temperature in the field. We were reaching over 40 degrees. And when we got this data, we realized that not only the canopy temperature is enough for the water stress detection. So in the following year, which was last summer, we were also getting data of the environmental temperature, the relative humidity, and the barometric pressure. So all these data were measured in very close to the canopy. And if you see the map on the right, we go back again to the NDVI. This map was done the same day that the grower was hiring a drone to make the maps. So it turned out that the same day that drone was making a map, we were making two maps with the robot, one in the morning, one in the afternoon. And guess what? The maps were not completely similar. So once we got this data, we realized that there are some benefits of having a high-resolution proximal sensing. First, we are getting the data around the canopies. So we cannot get environmental data from 90 meters above the ground. And the second is that we are hitting an area where we cannot get from above. So these are the results that we got so far, and it's getting complicated to understand the physiology of the plants. We are getting the temperature of the canopy because we know that when the plant is stressed, the stomata will close and the temperature of the leaf will rise. But this is a simple mechanism. When we want to get a little bit deeper, we realize that we need to get much more data, and not only close to the plant, but also at different points of the day and at different days of the week. So this is what we are trying to do now, is to understand how these plants are progressing. So, well, the platform so far is moving this way. So this is the vineyard where we have been doing all the tests. We are actually making wine of this vineyard. So still, we are not at the end of the road. We still need a lot of things to do. And but now that the navigation is working pretty well, we are getting, before we were worried because we didn't have enough data. Now our concern is that we have too many data. We don't have time to process all this data. We are getting like one measurement every meter, more or less. So it's thousands of points that we get every time we map the field. And still, we have some work to do with the navigation. Of course, the most complicated thing is the turning. We don't use GPS for guidance. We use only GPS for mapping. Guidance is done only with local perception, because we want to use, to offer a machine that can be used in any field without previous mapping or previous knowledge. So we, of course, have some requirements for the vines. They have to be with in VSP structure. They have to have a spacing between 1.8 and 2.5 meters. But it covers most of the European vineyards. And this is pretty much what I had. I was instructed to have only 3 slides, so I think probably I'm the only one who only had 3 slides. But I would like to leave some time for questions, and of course I will also be the whole day here in the Agora, and we have the robot in there, so you can just get close and take a look at it, and of course I will be happy to answer any question that you may have. Thank you.
And there's already one. There's a question in the upper room.
Aha, the microphone has made it. It's Richard Martin Hempel with Ag Funder News and a bit of a cold. I was wondering, what's your business model here? Because how do you sort of actually bring this to farmers?
Yes, it's one of the things that we need to think, because this project is a fast track to innovation. So this kind of projects have to, at the end, you need to deliver something that is close to market. So you need to think about the business model. So we have at least 2 or 3 options. The first option is the farmer buys the machine like they buy other machines. That's why we need to make sure that it's easy to use for them. So my complexity threshold is a cell phone. So if you can use a cell phone, you should be able to use this machine. The second business case would be a service company. They have the machines, they go, they do the mapping, they give you the information that you need. And a third would be just some companies that just sell the data for profit. So we probably can think of the 3 different business cases. The average vineyard in Europe is 3 hectares, and so we estimate that we would need a robot for 30 hectares. So 10 farmers could share one of the robots, so we would split the cost. And I offered this, and most of the farmers were happy. I was also told that you cannot make 2 Germans to share the same machine, so probably in Germany you will have 1 robot per farmer. But in any case, so we could also sell these machines to cooperatives, to irrigation societies, or to the denomination of origin. But we consider both. Selling the machine, so the farmer has totally control of it. They can, if the regulations allow to do that, they can just run the machine every day if they want. So they can charge in the night, run it in the morning. And of course, we have service companies that can offer to do the mapping and then sell the maps or upload the maps in a platform.
We have time for another question. Yes.
Good morning, Marc Andrieux with Bayer. I see you acquire a lot of data, high precision on vineyards, and applying to apparently water stress monitoring. Did you try to correlate the amount of data you get with other sources of stress, meaning disease, pest, and what you can bring actually with this technology to the table?
Yes, well, we didn't compare with other like diseases or pests, but what we did is try to get the ground truth of what we were measuring, which was really challenging. So for water stress, we used the Scolander chamber, which is really a heavy machine, and you need to have a team of people just working and doing that, and you can only get 20, 30 points, which also, from the statistical standpoint, is difficult. And we also used some sensors that was experimental design from Bosch, and it was a leaf sensor to give us the tension in the leaf as a measurement, as an extra measurement of water stress. But all this data is still being processed because it's difficult. We have in our maps thousands of points, and then we have from manually taken maybe 20, 30, 40 points. So we have some of other partners in the project are trying to get a model. But what is interesting is that the first years we thought that with the canopy temperature was going to be enough, and then we realized that we need to have the ambient temperature, the relative humidity, and the barometric pressure. And with this, they are trying to make a model, but still there's a lot of work to do. So we are not sure how reliable that model will be yet.